So now we're going to talk about whenever the acid is dissolved in water. So we're starting the series of calculating the pH, which is the main part of the this chapter, chemical equilibrium. So how do we calculate pH? We, after the chapter, I'm again telling that you will be able to calculate all the pH, all the types of pH: strong acid, strong base, weak acid, weak base. Mix each of them, mix whatever you want to mix. Finally, at the end of this topic chapter, you will be able to calculate the pH. So first of all, start with the pH of a strong acid. We're going to calculate pH of a strong acid. Whenever we have a strong acid, how do we calculate the pH? Now, what are the strong acid? Now, what is the strong acid? We know the strong acid are HCl, HNO3, H2SO4, and HClO4, and HCl, HBr, and HI. So here we have taken the HCl two times. So these are the six acids. So these are the six strong acids. So how do we calculate the pH of that? Right. So first of all, let's understand the basics that we know pH equals to negative of log of concentration of H plus. Now, whenever we are dissolving an acid, HA, let's say HA is acid, and if we are talking about strong, alpha should be 1, it will totally dissolve into H plus and A minus. And we have H2 also, which is a weak electrolyte which dissolve like H plus and OH negative. So, if both are in the same container, the sources of H plus is both the acid and water also. Remember, the H plus is coming from both. We will be later using this. Why we are accounting the H plus from H2O also. But remember, the sources of H plus is again the acid as well as water. Like, so actually if we write sources of H plus is HA and H2O, and sources of OH negative is H2 only. So here we can conclude then the concentration of H plus. The concentration of H plus is greater than the concentration of OH negative. So the concentration of H plus is greater than the concentration of OH. So that's why it is called the acidic solution. Now let's talk about the let's say strong acid concentration. So let's start with some examples, right? Like you have given example, you have 10 to the power negative 1 molar HCl. You have to calculate its pH. So we know HCl will dissolve into H plus and Cl negative. So it has when you have taken initially, it is 0.1 molar. Now when reaction completed, that is when we dissolved in the water, it's 0.1 molar. Now when it is electrolyzed full, it is broken into constituent ion, then it is 0.1 molar, right? So the concentration of H plus is 0.1 molar. So pH will be 1. Now if I gave you another example, like when we have 10 to the power negative 3 molar HNO3. So what will be the pH? So you know HNO3 will be dissolved in H plus and NO3 negative, right? So pH will be minus negative of log of 10 to the power negative 3, 10 to the power minus 3. So pH turns out to be 3. Now example we have H2SO4, that is 10 to the power minus 5 molar H2SO4. Now calculate its pH. We know H2SO4 breaks down to 2H plus plus SO4 negative 2. So H2SO4 initially 10 to the power minus 5, then it doesn't dissociate. When it is dissociated, it forms 2 into 10 to the power minus 5 molar into 10 to the power minus 5. So pH will be minus log of 2 into 10 to the power minus 5. That means the pH turns out to be 5 minus log 2, that is 4.7. So remember, the pH is how does we calculate these type of pH, right? If we look some more variations about the calculating of pH of a strong acid, you can take the general example. So like if I give you any example, calculate weight of H2SO4, which should be dissolved in 100 liter of water to change pH by 4 units. So calculate the weight of H2SO4 which should be dissolved in 1000 liter of water to change the pH by 4 units. Right. So if we know the pH, pH of first of all, if I give you some examples, you have to stay and you have to pause and try to answer it by your own. So I am giving you time. Just pause the video and try to figure out the mass of the weight of H2SO4 required. So here we go. The pH. Let's say pH final. Let's say initial pH was 7. We know the neutral water pH is 7 and reduces by 4 unit, and it will be reduced because we are dissolving the acid. Now pH final is 3. So the concentration of H plus comes out to be 10 to the power minus 3 because pH is we have written 3 equals to minus log of H plus. If we go in the basic definition of pH, so H plus comes out to be 10 to the power minus 3. So concentration of H2SO4, it is 10 to the power minus 3 by 2 mole per liter, right? Because we know 1 mole of H2SO4 will give 2 mole H plus. So if we are getting that much more of H plus, so it will be 10 to the power minus 3 by 2 moles of H2SO4. So volume is like 1000 liter. So weight will be 1 by 2 into 19, right? So number of moles will be concentration. If we where I'm explaining where 1 by 2 comes out to me. We have given volume, we know molarity, we know moles will be volume multiplied by molarity. 10 to the power 3 is the volume. Molarity is 10 to the power minus 3 by 2. So moles turns out to be 1 by 2. Now weight is 1 by 2 48 gram, and it to H2SO4 we will be dissolving in 1000 liter of water to reduce its pH by 4 unit. So these are some basic type of examples you may see while calculating the pH of strong acid. Now move further. Let's come into a relatively new part which might you have not learned previously. That's why you are here. So if you have given the pH of HCl, when you have given like 10 raised to the power minus 6 molar HCl, and you have given the value of pH, the concentration of pH, you may figure out to be, let's say pH, let's say you try to figure out it is negative log of H plus, that is negative log of 10 raised to the power minus 6, that is 6, right? So you will be directly telling when HCl is 10 raised to the power minus 6, well, pH is 6. But let's check something. We know that we have water also. When we are dissolving HCl, it will dissolve into H plus and Cl negative, and we have water also, H2O, which is dissolving like H plus and OH negative. So it was 10 to the power minus 6 molar. It was also 10 to the power minus 6 molar. But due to common ion effect, we know the H plus from HCl, or we can say Cl minus from HCl, will be same, because HCl is a strong electrolyte. It will be totally dissociated into H plus and Cl minus. It can't be go back. But H2 is a weak electrolyte. It can be reversed its direction. So H2 will reverse its direction. So it might be 10 to the power minus 7. No, it will be not the 10 to the power minus 7. We know H2O, when you give H plus and OH minus 25 degree, it is 10 to the power minus 7. OH negative is 10 to the power minus 7. But due to common ion effect, let's say it is X and it is also X. So the concentration of H plus turns out to be X into 10 to the power minus 6, and this turns out to be minus 6. We have seen that when we have H plus, it will not matter when it is in the container. It will not matter whether it is HCl is coming out from HCl, H plus is coming out from HCl, and H plus is coming out from H2. It is H plus. So we will be counting all the H plus in that and all the H plus in that. We won't be differentiating that this H plus is HCl. We know if it is in the same container, all the H plus we will be counting in the solution in this and in this also. So H plus and OH minus, right? So a concentration of H plus into OH negative will remain fixed and only varies with temperature. So a concentration of H plus is 10 to the power minus 6 plus X, and concentration of OH minus X, and it is 10 to the power minus 14. So let's expand is X square plus 10 to the power minus 6 into X plus 10 to the power minus 6 equals to 10 to the power minus 14. Wait a second, it is not making the square. Let's say X square plus 10 to the power minus 6X minus 10 to the power minus 14 equals to 0. So we're gonna use the quadratic equation to solve this equation, quadratic formula. X equals to minus B, negative of B. This is X square plus BX plus C. So negative A minus 10 to the power minus 6 plus minus under root of B square 10 to the power minus 6 square minus 4. A is 1 and C is negative of 10 to the power minus 14 divided by 2A divided by 2. So now on moving further, let's solve this. X turns out to be negative of 10 to the power minus 6 plus minus. We're gonna use plus only because H plus concentration can't be negative. So we're gonna use only plus. It don't have two solution, it has only one solution. So that is if you solve this, it will be coming out to be 1.04 into 10 to the power minus 12. Right, and this will become positive and it will become 0.04 into 10 to the power minus 12. If you take the common, it will be 1.04 into 10 to the power minus 12. Very simple calculation. So that X is turns out to be, let's say it is negative of 10 to the power minus 6 plus 1.02 into 10 to the power minus 6 divided by 2. So it is 0.01 into 10 to the power minus 6. So it is approximately 10 to the power minus 8. So the X turns out to be 10 to the power minus 6. So OH negative concentration is the X, that turns out to 10 to the power minus 8. And concentration of H plus turns out to be 1.01 into 10 to the power minus 6. And concentration of H plus turns out to be 1.01 into 10 to the power minus 6. Now, that is 1.01 into 10 to the power minus 6. And if you do the perfect calculation, you will get this answer. You might be confusing that when OH negative is, then how that could be H positive, right? But that is the real. The X is, if you take the 10 to the power minus 6 common, right? So it will be subtracting like 1.02 minus 1. So it will be actually 0.02. It is 10 to the power minus 8. No, it is 0.02 divided by 2. 0.01 into 10 to the power minus 6. H plus is coming out exactly 0.08. But H plus is actually 10 to the power minus 6 plus X. H plus Wait a second. H plus is coming out to be, if I write the value of H plus, the H plus was, it was 10 to the power minus 6 plus X. So it is 1.01 into 10 to the power minus 6. So the pH comes out to be, the concentration of H plus comes out to be 1.01 10 to the power minus 6. If we try to calculate the percentage error by dissolving 10 to the power minus 6 molar HCl into a neutral solution, that is the change in H plus divided by initial value of H plus. So that is 0.01 into 10 to the power minus 6 divided by 10 to the power minus 6 into 100. So that turns out to be 1%. So the change in 1%, if we include the water by it, the error is 1%. So we can say when we are using the 10 to the power minus 6 molar HCl, the pH is approximately 6. But would it be valid when we are using the concentration of HCl is 10 to the power minus 7? No, that will not be validating on that. So whenever we are using the concentration of H plus 10 to the power minus 7, the H plus will be having from both HCl plus H2O. Even if we are using concentration of H plus 10 to the power minus 8, concentration of H plus will have both the contribution HCl and H2O. But if we are using concentration of HCl as 10 to the power minus 9, then H plus from HCl will be very less. So it will be all from H2O. So there is a pattern you're gonna see whenever we are using the different HCl, the concentration of HCl keep on diluting. It is competitive with the concentration of H2O in the water. All am I saying is that whenever you are using concentration of HCl, here I am using concentration of HCl, I am using sources of H plus, and I am using concentration of H plus, and I am using the pH. So let's say you have taken 10 to the power minus 5 molar HCl. Undoubtedly source of H plus is HCl. The concentration of H plus is 10 to the power minus 5 molar, and pH will be exactly 5. But when we are using 10 to the power minus 6 molar HCl, the source of HCl, H plus will be HCl only. The water is competitive when the concentration is approximately 10 to the power minus 7. So the H plus concentration will be 10 to the power minus 6 molar that we have calculated, pH will be 6. Whenever we are using 10 to the power minus 7 molar HCl, now the water will also include, because the concentration of H plus in the pure water is also 10 to the power minus 7, and HCl also given 10 to the power minus 7. We will be using common end effect. We will be using the quadratic equation. Now the sources of HCl, it comes from HCl and H2O both. Now if we are using the quadratic equation, we can calculate. It will come out to be 1.62 into 10 to the power minus 7 molar. How do we calculate? We have calculated the previously in case of 10 to the power minus 6. You can replace direct concentration of HCl as 10 to the power minus 7. Now the pH turns out to be 6.79. The concentration of HCl is 10 to the power minus 8. The sources of H plus is HCl and H2O both. The concentration of HCl by solving the quadratic equation comes out to be 1.05 into 10 to the power minus 7 molar, and the pH comes out to be 6.97. Now the source of H plus is 10 to the power minus 9. Now we see that the H2O gives 10 to the power minus 7 molar HCl. Now 7 molar H plus. When we are using the 10 to the power minus 9 molar HCl, that means the water will dominate. The H plus from water will dominate. So the source of H plus will water only. So it is 10 to the power minus 7 molar, and the pH comes out to be 7. Right? So these all things you're gonna see when we are using the strong acid, how the pH will. When you are giving the 10 to the power minus 7 molar of H2SO4, you can go on the basic that H2O is also present. You're gonna apply the quadratic equation. Then you may solve it directly. If I give you an example, you have given 10 to the power minus 7 molar H2SO4. Calculate pH. So what you will be doing? You will be doing H2SO4, and the H2SO4. Wait a second. H2SO4 gives 2 mole of H plus. The H2SO4 will give 2H plus SO4 negative. So it will be 2 into 10 to the power minus 7 and into 10 to the power minus 7. It won't be come back. It won't be dissolved again to H2SO. But H2 we have over here, it will give H plus and OH negative. Let's say it is X and it is X. Due to common end effect, it has gone, it is not equal to 10 to the power minus 7. It must less be 10 to the power minus 7. So you will be doing X here and you will be adding 2 into 10 to the power minus 7. So again you will be using H plus and OH negative as 10 to the power minus 14. So you will be solving 2 into 10 to the power minus 7 plus X into X as 10 to the power minus 14. You will be calculating X, you will be put over here, you will be finding the concentration of H plus. Right, you will be finding the concentration of H plus by using that quantity. So it is you must be very clear, whenever the concentration of a weak and the strong acid is approximately equals to the concentration of H plus that has been given by water, we have to use the quadratic equation.